Um, First of all, I would like to start from the introduction of the ndis concept. Basically, this project actually is for rootkit monitoring at kernel level. Before we go deeper about the structure of ndis, let me go through the basic concept of ndis. First of all, ndis stands for the Network Driver Interface Specification. It's an application programming interface, API, for a network interface card. Short form is a NIC card. It also is a specification for network driver architecture that allow transport protocols such as a TCP/IP, IPX to communicate with underlying network adapter or others hardware adapter, hardware devices. So if you refer to OSI reference model, and this actually is a layer exists between the layer network and layer data link. This diagram shows you the overall structure of ndis. As you can see from the slide, ndis is placed between network protocols such as TCP/IP and network interface card. This slide shows you more detail regarding what is ndis structure. Basically, ndis divided by 3 levels. First level is on top is a interface TDI. So the second is ndis intermediate, and the lowest is a layer mini port. So for level TDI, or you also can call it a level protocol. Level intermediate acting like mini port, and from the other side, for level mini port, intermediate acting like TDI. So from this diagram, actually ndis intermediate is sitting between TDI and mini port. So you can say that actually some sort of like man in the middle attack between TDI and mini port. So this structure actually can make sure every network flow in to your PC can direct bypass, go through the ndis intermediate. So this is why I continue this project to intercept it, because in this level, actually you can monitoring, you can intercept every packet flow into your NIC card. Besides of ndis structure, it's also very important to understand the ndis packet structure as well. Protocol driver also is you can call it, just I already mentioned, you can call it a TDI driver, allocate an ndis packet, fill it with data, and pass it to the lower ndis driver. And on the contrary, lowest level NIC driver allocate packet to hold receive data and pass the packet to higher layer driver. So this diagram shows you the relationship between ndis packet, ndis buffer, and virtual memory. For the packet descriptor, actually this packet descriptor is contain the private area for the mini port driver and protocol driver. A packet descriptor is a set, contain a set of flags associated with the packet, and host meaning is defined by a cooperating mini port driver and TDI driver. The number of physical pages that contain the packet, or the total length of the packet, and a pointer to the first buffer descriptor that map the first buffer in the packet. So all the this kind of definition is actually defined of the variable inside the packet descriptor. Second, for the buffer descriptor, basically buffer descriptor describes the starting virtual address of each buffer. The buffer byte offset into the page point to by the virtual address. So the total number of bytes in the buffer and point to the next buffer descriptor, if have any. Lastly, for the virtual page, possibility spanning more than one page that make up the buffer described by the buffer descriptor. This virtual page were mapped to the physical memory. So we already go through all the basic concept of the ndis and ndget, blah, blah, blah. So now we come to the more interesting part. This is starting off what I'm doing in my project. So for the interception and blocking, this is core of my project. Overall, the design of the interception and blocking is divided by to three parts. The first is a interception of sending and receiving network traffic packet. Second, I implemented the implementation of scanning and checking algorithm. Lastly is the passing or blocking the ndis traffic packet. So for the first part, for the receiving and sending routine in the ndis framework, the flowing of traffic through the ndis intermediate driver was intercepted by the analyst packet function. This function actually is written by me. So from this function, actually you can notice a few variables you need to take note. First is a ndis buffer. Of course, it's a stand for the ndis buffer. So the variable is very straightforward. And then second is a total package length, which means the total size of byte we send into your PC and send out from your PC. And another variable is I want to highlight is the string T, the definition of string T. This string T actually, from here, you can put any signature for the malicious traffic which you want to block. Let's say you want to block the cell code A for the exploitation. For those who doing the research in exploitation, you should know cell code. So after exploitation process, you will launch the cell code, and whatever cell code can doing is like reverse cell, or just open some port. You can just mine the port number and direct to access the PC. So how can you block the cell code to running after the exploitation process? So you can grab some unique string. For example, this $1/1 is a unique string, which is belong to the virus.exe. Later I will go through the demonstration process. And then you put into this source code, and you recompile the source code and install in the PC. For POC purpose, I implementing a very basic and simpler string comparison algorithm in ndis intermediate driver. For example, this block of the code, we're doing the scanning on HTTP traffic, which is containing string T. So it depends on how you want to block which traffic. Let's say you want to block the traffic which is connect to the google.com. You can put the string google.com in 3, and you recompile the driver, the source code, and install your PC. So whoever using the PC cannot connect to google.com anymore. So for the P packet contents, actually is a stand for the total package length. This means every package, every traffic packet flow into your PC and send out from your PC actually collected in this P package contents. So you should take note for the P package byte 12 and 13 is filter out the IP package. 12 and 13 is filter out the IP package, and for this case, proto TCP is filter out the TCP package, and for those TCP package, you should looking for the P packet content 34 and P packet content 35 is equal to 80. This is a source port number. So let's say this is a receiving package. So what this block doing is already filtered out. First, is filter out the IP package, and second, filter out the TCP package. Third is filter out the source port number. So what this block doing is it's trying to just looking for the receiving HTTP traffic. So after filter out all the package, you can start doing the scanning process, which is just I already mentioned, is a string comparison algorithm. So we'll start doing the scanning, start from the byte 54 until the end of the packet size. So this is one of the example of HTTP package. It's a receiving HTTP package, not sending. As you can see, total byte of the Ethernet header and IP header is 34 byte. So the first 6 byte is a destination MAC address, and the second 6 byte is a source MAC address. So what interesting in this structure is a few important value you need to take note in, especially in ndis framework. The most important value in Ethernet header is byte 13 and 14, which is defined the package belong to IP, ARP, or RARP. So if your value byte number 13 and 14 is equal to 0800, this means the package you receive is belong to the IP package. So another important value such as the protocol, which define protocol ICMP, IGMP, TCP, or UDP. So for example, if the protocol is belong to 06, this means this package is belong to the TCP package. So secondly, for the TCP header structure, what you need to know is byte number 34 and 35. 34 and 35 actually stand for the source port number. So let's say the source port number is belong to 0050 in hexadecimal. If you convert to decimal is equal to 0080. This means this package is receiving HTTP traffic. So in this slide, my string comparison algorithm is starting doing the scanning from here, 02, 04, and doing the scanning, see any string actually is matching. Lastly, the ndis will perform the action either passing or blocking the network traffic packet. So the proof of concept, we are going to show you the idea how ndis are intermediate driver to intercept and block malicious code. I have prepared the scenario of the demonstration. I'm using an example of integer overflow in Adobe Flash Player. It's considered it's a very old vulnerability. It's, if not mistaken, it's happened last 2 years. I also come out the malware sample as a payload for Flash exploitation. And lastly, I will demo how the ndis intermediate driver success to intercept and block the Adobe Flash vulnerability exploitation process. Let me go through the scenario. First, the attacker already compromised the server 192.168.1.1. And the attacker planted the malicious file in server. When the victim user browsed to the server 192.168.1.1, the malicious SWF file is a software object file. It belongs to the Flash file. Will load you download and exploit the vulnerable Adobe Flash Player application which is running in computer user 192.168.1.2. This exploitation process will download and install the backdoor in victim computer. So here I'm preparing the two machines for the demo purpose. So let me go through one by one. So this is the server 192.168.1.1, which is already compromised by the attacker. Let's assume this scenario. So first, I enable the browse, the web server services. This easy PHP, when you enable it, so 192.168.1.1 is acting like web server. Second, the attacker is copy and install the malicious file. This exploit.swf file actually is aimed for the attack the vulnerable Adobe Flash Player version 9. If the exploitation success, you will auto running the virus.exe, and this virus actually is just running the virus infection. It's a virus demo. For the server, sorry. So for the server 192.168.1.2, actually is a normal user. When you browse to the When browse to the 192.168.1.1, you can see the file which is installed in server 192.168.1.1. So first, I need to disable my ndis intermediate driver. How to disable it? I just uncheck. After you install the ndis intermediate driver, it will show out the one virtual NIC card inside your network properties. So how you can disable the ndis intermediate driver? You just uncheck it and you click OK. Okay, we already disabled the ndis intermediate driver. And then another thing I want to highlight here is inside this user u192.168.1.2 is contain one original.exe. So it's just another pop-up message. It's just this is test file, blah blah blah, something like that. So when the user click the exploit.swf file, you are success to run the virus.exe, which is contained in this server. So this means the exploitation process already success, and it launched the attack, the virus which is running in this web server. So this virus.exe actually infect the original.exe, and you can see that the original.exe already infected, but the basic function still running as normal. So here what I'm going to tell you is how the Adobe Flash vulnerability, the process of how the attacker using this kind of vulnerability to attack your PC. So let's say the attacker is put the link 192.168 blah 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 and this /exploit.swf file. The attacker go and attack and compromise the web server, which is vulnerable to SQL injection. It just insert the link inside the web server. So let's say the attacker already success compromise google.com, let's say. Everyone now every day. The first page is a google.com, right? So when you open the google.com, actually it's already contain the malicious embedded link, which is linked to the 192.168.101. So this is just a concept. So now I'm going to show you how the ndis intermediate driver to block this kind of exploitation process. First, I need to clean the cache file, because just now the virus.exe already loaded into the victim PC. So now I need to enable again the ndis intermediate driver. Okay, and I cross it. And I'm using the debug view to display all the package which is captured by ndis intermediate driver. All the traffic, no matter sending into your PC or sending out from your PC, actually will display, will send to the debug view and display to you. So now we start again the exploitation process. So you will, from here, you can see my string comparison algorithm already working. It's doing the scanning, like signature match fail, and last will show out the success, and my ndis actually is blocking the malicious traffic detected. So you can see that the browsing process actually not it's totally different if compared to the first scenario. So this means the exploitation process already success to intercept by ndis intermediate driver. So this is just for just in case here cannot detect any my VMware server. So I just screenshot and try to show to you all if something happened to my PC. So the first screenshot is successful of exploitation Adobe Flash Player vulnerability, and this screenshot actually is how to create the signature of a string comparison algorithm. So from this slide, you can see actually is you can open the virus.exe. If let's say you have the sample, you just grab the Unix string and put in the source code and doing the comparison and install into your PC. And here is you can enable and install the ndis intermediate driver. And this is a screenshot how the intermediate driver is doing the scanning and blocking. So this is for today's, thank you. Any question?
Okay, so intercepting the network, the traffic on the network driver is pretty smart, but nowadays there are frameworks like the Windows firewalling framework.
Yeah.
What is the advantage of your approach over the Windows firewalling framework?
Okay. So why everyone, when I'm talking about the in-network ndis intermediate driver, everyone will ask me why you're doing this because it seems like we already have the HIPS, we already have the firewall system, we already have the antivirus. Why we still need it? It's because ndis intermediate driver is like just now I show you the structure. The ndis intermediate driver actually is stand lowest level belong if you compare to the TDI. even for the Wireshark, it just intercept all the network in TDI level. But the ndis intermediate is then lower, one layer lower than TDI. So what another advantage is ndis intermediate driver is acting like some sort like man in the middle. So it will protect, you avoid from like someone, the attacker, using rootkit technique to hook into the TDI to bypass your interception and your sniffing regarding the network traffic. So this is why I say the ndis intermediate driver is the best. Yeah. And another thing I can say to you all is it's just not finished yet. It's just a demo. It's just a proof of concept. Actually, this my ndis.dat. Actually, every package is sniffing using my ndis intermediate driver. All the traffic will dump to this file. But the worst is not finished yet because I'm planning to dump in the PCAP format, which you can using Wireshark to open it. But now it's just in alpha version, not finished yet. When you open it, every traffic actually is you can see you can't use any tools to open it, just a notepad. Yeah. But every package is a direct dumping from driver level. It's not like Wireshark. Wireshark is just sent to the ring tree application and display to you. It's very convenient. But here, this traffic actually is a direct dumping from driver level. This means it's faster than Wireshark. Yeah. Any question?
Can you detect rootkits that are based on intermediate drivers?
Yes, yes. This is why I start my project. The first thing I start this project is because our malware research center is doing something. It start the project to so-called malware tracking project. Is to monitoring, we will install and running the malware live in isolate lab. And then we are thinking now the malware coder day by day is become smarter. They start doing the rootkit. We discover one malware sample which is using the rootkit technique, it totally bypass the Wireshark, bypass the like nstat-an to checking the port number connection. Because this malware actually is using the rootkit technique to bypass everything. It's direct hook into the ndis driver. It's the sound I mentioned. It's the ndis TDI. It's the first level of the ndis driver. So we are after discussion we doing the research and another thing we come out the solution is using the ndis intermediate driver. Because this ndis intermediate driver is acting like man in the middle, it's impossible you can use a hooking technique to hook this layer. Okay?
Okay.
Any question? Yeah. Thank you.